Hello again, and welcome back to another CodingBytes speedrun. In this speedrun, we're going to be going through a lot of the creation of new methods in Java, and we're going to be working with a lot of the existing things we've learned. So I highly suggest, if you haven't seen my previous speedruns, go ahead and watch them before that and do the activities that I'm doing there, and that will get you up to speed with all the knowledge you need to know to continue from this speedrun onwards. So let's jump right into the code. Right, as you can see here, we're going from challenge 45 to 50 in this speedrun, and they all concern methods. So the first question is to write a method header with that returns an integer named sum to x. And if you notice, there's no code inside the curly braces, unlike the previous challenges. So not only do we have to write the method header, we also have to write all of the code in the method ourselves. Right, let's jump right into it. So it has to return an integer, and it has to be called sum to x, and it takes as an input an integer called x, so int x. Okay, it wants to calculate the sum of the integers from 1 to x. Okay, so this isn't too hard. We will do this using a for loop, but first we want to initialize a variable, which will be the sum of the numbers. So we have to go int sum is equal to 0. Set that to 0 at the start. Now we want to loop through all of the numbers between 1 and x. So int I equals 1, I is less than or equal to x, I plus plus. And now we want to have the sum, we want to add I to the sum because that I is the current integer and we want to add that to the sum. Finally, we want to return the sum. And that's about it for this challenge. So if we run this code, we get our two tests as 5 and oops. Have I spelled this wrong? Static in sum to x. Oops. Sorry, let's try that again. So as you can see, we have our two test cases, 5 and 7. These are the correct outputs, and we also get the correct outputs. So we've completed this challenge successfully. So if we run this test, we'll see that we've got it all correct, and we'll move on to the next challenge. Next, we want to write a method header that returns an integer, so static int, named sum even to x, and we want to it takes in an integer called x, and we want to calculate the sum of the even numbers from 1 to x. So we only want to get all the even numbers. So how do we do this? So we want to use a for loop with similar code to the previous challenge. So int sum is equal to 0. For int I equals 0, I is equal to 1, I is less than x, I plus plus. What is it called? Sum plus equals I. And the only thing we have to change is that we only want to sum the even integers. Since we know this starts at 1, we might as well make it start at 2, since we know that 1 is not an even integer. And the only other thing we want to do is add 2 to it every time. It won't matter whether the input number is odd or even, because if it is an odd number, this loop will stop looping through it at the even number just before the number. And finally, we can return the sum, and this should be all. So if we run the code, as you can see, it's only outputting 12. That is interesting. I is less than x. Oh, so this includes x as well. Okay, so I should say less than or equal to x. My bad. Okay, now it should work perfectly. As you can see, we get the correct output, 6 and 20, and so we've completed this challenge successfully. Okay, on to the next one. So we want to write a method that returns an integer, and it's named sum5's range. And it takes in an integer called a and an integer called b. So a is the start of the range and b is the end of the range. And it wants to calculate the sum of the multiples of 5 within the range a to b inclusive, including b. Right. Well, the first thing we want to do, okay, so the lazy way to do this would be to write a for loop that goes something like, for int I is equal to a, I is less than b, less than or equal to b, I plus plus, and then we go if I is divisible by 5, then we, sorry, forgot to put a sum, and sum is equal to 0. Then we want to add I to the sum, and we want to return the sum. And this would work, but this isn't the best way that we could write this code. There's a much better way we can write it. I mean, as you can see, it returns the correct answers. But the best way to write it is to convert A, our starting boundary, to an existing multiple of 5, the smallest multiple of 5 that is greater than A. So how are we going to do that? We can say A is equal to A minus 1 divided by 5 times 5 plus 1. Divided by 5 times 5 plus 1. So this looks like it might not do anything, but we have to remember that this is integer division. So what's going to happen with this math? So if we put a number, say 4 through it, 4, so we have the new number is equal to 4 minus 1, that's 3, divided by 5, which is 0 because it's integer division, times 5, which is 5. So 1 divided by 5 times 5 plus 1, that's equal to, this is equal to, 4 minus 1. So this is equal to 3 divided by 5 times 5 plus 1. It's equal to 0 times, oh wait, I made a mistake. We should be adding 1, I believe, here. 3 divided by 5 plus 1 times 5. Oops, wrong way around. Anyways, 3 divided by 5 is 0, 0 plus 1 is 1, 1 times 5 is 5, and that's the smallest multiple of 5 less than 4. Let's try it for another number, 16. Hold on. Okay, 16. So we have 16 minus 1, that's 15. 15 divided by 5 is 3. 3 plus 1 is 4. 4 times 5 is 20. And 20 is the least multiple of 5 greater than 16. Finally, let's try it for a multiple of 5 just to check it works. So 15 minus 1 is 14. 14 divided by 5 is equal to 2. 2 plus 1 equals 3. 3 times 5 is equal to 15. And so we get the smallest number inclusive. So now let's put this code in. So we got A is equal to, why did I just delete the code? A minus 1 divided by 5 plus 1 times 5. And this will convert A to the correct starting bound. So now what we can do is instead of I plus plus, we can just add 5 each time to A because we know A is a multiple of 5. And if we add a 5 to a multiple of 5, we get the next multiple of 5. And so that's pretty much it. So we've made this code more efficient, and it should work exactly the same, except I forgot a semicolon. And it should work exactly the same as we can see here. So that's how to make your code a bit more efficient. Okay. Now, next challenge, we want to write a method that returns an integer named countA that takes in a string called s. Okay. And we want to count the number of occurrences of the lowercase a or the capital A within s. So to write a for loop that loops through a string, we've done this before. We have to go for int I equals 0, I is less than the string's length, and we add 1 to I each time. And to get the character at this position, we go s.char at I. So now we want to count the number of occurrences of A or A. So, sorry, lowercase a or uppercase A. So let's check if s.char at I, actually let's save this into a variable, it'll be a bit faster. Char c is equal to s.char at I. If c is equal to lowercase a or, remember these two like straight lines are the symbol for or. C is equal to the uppercase A, then we want to add 1 to the count. So actually, let's make a count variable here, and count equals 0. And every time we see one of these characters, we want to add 1 to the count. Finally, we want to return the count itself, and that should be all of the code. So if we run this, we can see that it is working perfectly. So yeah. Yeah, let's wait for the test to run, and we'll move on to the next challenge. Okay, so next we want to write a method that returns an integer, and it's good that they have a lot of these problems. This will get you up to speed, make sure you fully understand how to write methods, and integrate everything we've learned so far. So static int, want to name it count vowels, and takes in a string called s, and we want to count the number of vowels in the string. Okay, so first let's initialize a count variable to 0 and create a for loop that loops through the string. S.length I++, okay, and we want to count the number of vowels. So let's save the character at its current position. So char c is equal to s.char at I, and we want to test if this is equal to A, E, I, O, or U. We could use like a switch statement, but I'm not feeling it right now, since also we do the exact same thing for each case. I guess you could use it. It might look a bit better than this, but this will also work just fine. So in the case that is a value, it is a vowel, and we want to assume it's all in lowercase, so we don't have to cover the uppercase stuff. Then we want to add 1 to the count, and finally we want to return the count again. And if we run this code, oh wait, hold on. Yeah, the count vowels. Yeah, okay. If we run this code, taking a while. Anyways, we got the correct answers, so it's all good. Now, let's move on to the last challenge of today. After we run the tests. Okay, those are all good. Now we can move on to the final challenge. So, we want to write a method header that returns a string named keep vowels, and it takes in a string called s. And we want to create a string that is composed of all the vowels in the string in the same order that they appear. Okay, so actually to do this, I want to copy our previous code because I don't want to type out the long if statement, and we're going to reuse the for loop and the if statement. It's just that instead of having a count, we want to, can't add char to string. Okay, we want to create a string, like our vowel string, let's call it that, and set it to an empty string. And now the only thing is we can't add characters to strings, so we're actually going to have to get the substrings of at this position, which we can get by using the method substring I+1. And the single quotation mark is used in Java to create a character, and we don't want that. We want to make a string, so we're going to have to replace all of these single quotation marks with double quotation marks. It's Command F in REPL to open up its replace dialog, and if we hit replace and replace all of them, as you can see, it's converted them all into strings. Now, finally, we want to edit this code so that instead of adding 1 to the count, we actually add the current substring to the vowel string. And I've just thought of something because I'm being silly. We don't want to use this equality operator. Usually we want to use the dot equals operator. And so just test if the C equals any of this. There might have been a faster way to do this. I think definitely in this case I might have used the case statement. But since we already have all of this code written out, I think we might as well just use it. Okay, there. So now finally, we want to return the vowel string, not our count. So if we run this code, so you can see hello should be EO, and oopsies, I did not set this to an int. Sorry, a string I meant, so let's change that. And as you can see, we get the correct output. So as long as this test passes, which I think they will, that will be all for this speed run. So hopefully you now have a better grasp of how to integrate all of your Java knowledge into solving some problems. I highly recommend that there are 6 more of these like problems, and I highly recommend that you try them out before watching the next speed run. If you like this video, please leave a like, and if you have any comments, leave them down below, and as always, make sure to subscribe for more awesome coding content. See you next time!